Now we've got our 0800 Sunline. We're going to have 2 morning Sunlines. I'm going to break it into 2 separate videos because while it would be nice and convenient to do them both at once, that's not how you actually do it in reality. You do all the math for your stars at the same time because you took them at basically the same time. But our Sunlines happened at 8 a.m. and 10 a.m. So in those 2 hours, when you had taken the first one and you were waiting on the second one, you would have plotted out your first Sunline, and now you'd just be waiting to plot out your second one. So we're just going to do our first Sunline. Set it up as usual. Firstly, we need our DR position. So we need to find what our DR position for 0800 was. If this is our 0727 DR, we're going to find, see the difference there is 33 minutes. So 33 times 15 divided by 60 is 8.2 miles. So 8 miles is close enough. There's 8 miles. So that's our 0800 DR. And to make things easier, while we don't need to, we're not going to do all the math for the 1000 DR, might as well just find its position here as well. So 2 hours is 120 minutes times 15 by 60. Oh wait. It wasn't at 0800, it was at 0811, so we're going to have to move that ahead. But it'll make things a little bit easier anyway if we get our 01000 DR as well. So while that's helpful for a general understanding, we actually have to bring this to 0811. So we're going to move forward another 11 minutes. It's 3 miles. So that's our 0811 DR position. You're going to have a lot of DR positions by the end of your project. See, that's got us a latitude of minutes seem to be 50. It's always hard to say when it's right at the top here. It looks like 56 minutes. So 17 degrees, 56.0 minutes north. Longitude is right there. 5 minutes. So 162 degrees, 05.0 minutes east. There we go. Now we can actually start to set up the problem. So zone time, zone description, GMT. Then we're going to get GHA hours, minutes and seconds, GHA of the sun, of course. Assume longitude, LHA. Then over here we're going to do deck, assume latitude. And then after LHA, I want to show you that you can really quickly set this up in advance once you get good enough at it. There's our full HC and ZN problem. And we can do HS, IE, dip, HA, main, HO. Then at the very bottom, we'll write our assume latitude, assume longitude, ZN, and A. At some point, you can just bang all this out in a second. All right. The zone time was 08:11:20. Zone description is still -11. So that's going to give us now, let's see, 24 plus 8 is 32. -11 is going to be 21. 11:20. It is nice that we don't have to deal with chronometer error. So now that we've got that time, we can open up. I, again, forgot the page. Here we go. November 3rd for the sun. At 2100, we've got a GHA of 139 and 6. 139 degrees, 6 minutes. We have a declination of south 15 degrees, 14.3 minutes. South 15 degrees, 14.3 minutes. And the little d is still positive 0.8. All right, now that we have that, we can come to our minutes and seconds. We're looking for 11 minutes, 12, 11 minutes, and 20 seconds. So we come down to 20. For the sun and planets, we get 2 degrees, 15 minutes, and little d is 0.8 is equal to 0.2. Okay. Little d equals 0.2. Now we just got to run through 56.0 and then 141 degrees plus 0.2. We're going to get south 15 degrees, 14.5 minutes. Assumed latitude we'll know is still going to be 18 degrees north. Our assumed longitude, we're in the east, so we need to add. So we're going to have 4 minutes east here because they're going to add to 60. And if our assumed if our DR longitude was 162 degrees 05, then we know that the closest possible assumed longitude is going to be 162 degrees 04. So we don't even need the diagram for that. Now we add these two together, carrying the ones here. So we're going to get 142 plus 162. Gives us 304. Good. Now we have our LHA, latitude, declination, ready to run through our site reduction. Much faster too, because we've only got to do it once here. So LHA of 304 degrees in the first half of the book. Number 3. Here's 304. We're still in contrary because the sun is still in the south. And we're looking for a latitude of 18 and a declination of 15. Yeah. Wait. It's our previous, the azimuth had 15 as well. Okay, yeah. So 15. So here we get 117.3. I'm going to write that out once I can find my pencil. Oh, sorry, wait. I forgot that we're not doing azimuth anymore. We're going to need all of the information. So 15 gave us a height of 25 degrees, 42.2 minutes, a little d of minus 29.2, a z of 117.3, and a z1 plus 1 of 118.3. Good. So our difference between the two is, between these two is plus 1. And then here it's minus 29.2. We're going to multiply both those differences by the minutes of declination, which is 14.5 over 60. 14.5 over 60. We're going to get, let's see, 14.5 divided by 60 times 29.2 gets us 7.8. So we're going to subtract that from 42.2. Gets us 35.1. So 25 degrees, 35.1 minutes is our HC. Z, we're going to do 14.5 divided by 60 times 1. I'm going to add that to 117.3. It came out to 0.2, so we're going to do 117.5 degrees. And now, of course, we have to consider this. So check our rule. We're in the north. LHA is greater than 180, so ZN is equal to Z. Good. So our ZN is also 117.5 degrees true. Now we can carry over to start with. 18 degrees north is our assumed latitude, 162 degrees 4 minutes east as our assumed longitude, and a ZN of 117.5 degrees. But we still need our HS to HO. So HS listed in the problem gave us 24 degrees, 57.2 minutes, the actual height of from the sextant. Our IE is still 0.3 on, and our dip is still 54.4 feet, which we know is still minus 7.2, so we don't have to look into the book for any of that information. We can go straight to finding HA. So 57.2 minus 0.3 minus 7.2 gets us 49.7, 24 degrees, 49.7 minutes. So now we can come to our main correction. Okay. For the sun, by the way, this whole problem was on the lower limb. We're in November, so October to March, and we have an HA of, where was it, 24 degrees, 49.7. We come down, we get plus 14.2. We're going to do plus 14.2 minutes. We add 14.2 to 49.7. We get 25 degrees, 03.9 minutes. So now we have HO and HC, and we can compare the two and find what our intercept is. So HC is greater than HO. We already know it's going to be away. So we're going to do 35.1 minus 3.9 gets us 31.2 minutes away. Good. Now we're ready to plot. So we had an assumed latitude of 18 degrees, an assumed longitude of 162 degrees, 4 minutes. So I'm going to really quick measure out 4 minutes of longitude. I'm going to put it right there. There we go. Now our intercept, our azimuth was a 117.2, or 117.5. So we're going to measure 117.5. There we go. Solid that way. Dashed line in the opposite direction. And we are going 31.2 miles away. So we'll do something's wrong here. Okay. This gets us an intercept right, or a line of position right here. Lower limb of the sun, 0811. And it's really far away from our DR position. Again, there's always the possibility I did something wrong. However, I think this problem, I might have to just throw out all these videos. I don't want to, but I think this problem is just bad. I guess our original assumption of moving our DR position back to 540 might have been wrong, and then they had only just messed up the first one, because if we had everything advanced an additional 2 hours, or nearly 2 hours, that would have gotten like 0812 to 540 here. It would put us like over here, meaning that this shot here would actually be perfectly reasonable. I mean, it would throw off the shot a little bit too, because our assumed longitude would be different. However, it would be closer, and I think that that's what they did, is they messed up the morning stars, but then didn't change anything else off of them and kept everything else the same, meaning we were wrong in trusting them, whoever made this. Because there's no point in going back and trying to rework this, I'm just going to do the next Sunline and hope that the same incorrectness follows through and they can kind of be kept together. This is a problem of trying to just find random old notes and use them. However, all this math is still coming out right. And I hope it's still representative of the work you're going to have to do.